Ethereum is a decentralized blockchain network powered by the Ether token that enables users to make transactions, earn interest on their holdings through staking, use and store non-fungible tokens or NFTs, and trade cryptocurrencies, play games, and use social media and so much more. Many consider Ethereum to be the internet's next step. If centralized platforms like Apple's App Store represent Web 2.0, a decentralized user-powered network like Ethereum is Web 3.0. This next-generation web supports decentralized applications, or dApps, decentralized finance, DeFi, and decentralized exchanges, DEX. This video will provide you insights on the history of Ethereum, how Ethereum works, its pros and cons, and a glimpse of Ethereum 2.0. Ethereum wasn't always the second largest blockchain project in the world. Vitalik Buterin actually co-created the project to answer for Bitcoin's shortcomings. Buterin published the Ethereum white paper in 2013, detailing smart contracts, automated immutable if-then statements, enabling the development of decentralized applications. While dApp development already existed in the blockchain space, platforms weren't interoperable. Buterin intended Ethereum to unify them. To him, unifying the way dApps run and interact was the only way to maintain adoption. Thus, Ethereum 1.0 was born. Think of it as Apple's App Store, one space for tens of thousands of different applications, all abiding by the same rule set. Only that rule set is hard-coded into the network and enforced autonomously, with developers able to enforce their own rules within dApps. There isn't a central party, like with Apple, changing and enforcing regulations. Instead, the power is in the hands of the people, who act as a community. Of course, building such a network isn't cheap, so Buterin and his co-founders Gavin Wood, Jeffrey Wilkie, Charles Hoskinson, Mihai Alisi, Anthony DeLorio, and Amir Chetrit held a token presale to raise around $18 million US in Ether, funding Ethereum's present and future developments. The group also founded the Ethereum Foundation in Switzerland with the mission to maintain and develop the network. Soon after, Buterin announced that the foundation would run as a nonprofit, which caused some co-founders to leave. Over time, developers came to Ethereum with their own decentralized ideas. In 2016, these users founded the DAO, a democratic group that voted on network changes and proposals. The organization was backed by a smart contract and circumvented the need for CEO heralding power over Ethereum. Instead, a majority needed to vote on the changes for them to be implemented. However, this all went south when an unknown hacker stole $40 million in funds from the DAO's holdings due to a security exploit. To reverse the theft, the DAO voted to hard fork Ethereum, diverging from the old network and upgrading to a new protocol, essentially undergoing a major software update. This new fork retained the name Ethereum, while the original network exists as Ethereum Classic. How does Ethereum work? Like Bitcoin, the Ethereum network exists on thousands of computers worldwide, thanks to users participating as nodes, rather than a centralized server. This makes the network decentralized and highly immune to attacks, and essentially unable to go down as a result. If one computer goes down, it doesn't matter because thousands of others are holding the network up. Ethereum is essentially a single decentralized system that runs a computer called the Ethereum Virtual Machine, EVM. Each node holds a copy of that computer, meaning that any interactions must be verified so everyone can update their copy. Network interactions are otherwise considered transactions, and are stored within blocks on the Ethereum blockchain. Miners validate these blocks before committing them to the network and acting as transaction history or a digital ledger. Mining to verify transactions is known as a proof-of-work consensus method. Each block has a unique 64-digit code identifying it. Miners commit their computer power to find that code, proving that it's unique. Their computer power is proof of that work, and miners are rewarded in ETH for their effort. Also, like Bitcoin, all Ethereum transactions are entirely public. Miners broadcast completed blocks to the rest of the network, confirming the change and adding the blocks to everyone's copy of the ledger. Confirmed blocks cannot be tampered with, serving as a perfect history of all network transactions. But if miners are paid for their work, where does that ETH come from? Each transaction comes with a fee called gas, which is paid by the user initiating the said transaction. That fee is paid to the miner who validates the transaction, incentivizing future mining and ensuring network security. Gas essentially serves as a limit, restricting the number of actions a user can make per transaction. It's also in place to prevent network spam. Because ETH is more of a utility token than a token of value, its supply is infinite. Ether consistently enters circulation in the form of miner rewards, and it will with staking rewards as well once the network moves to proof of stake. In theory, Ether will always be in demand, meaning inflation should never devalue the asset beyond use. Unfortunately for many, Ethereum gas fees can run quite high based on the network activity. This is because a block can only hold so much gas, which varies based on transaction types and amounts. As a result, miners will choose transactions with the highest gas fees, meaning users are competing to validate transactions first. This competition pushes fees higher and higher, congesting the network during busy times. Network congestion is a significant problem, though it's being addressed in Ethereum 2.0. A complete overhaul that will be discussed as a separate section. Interacting with Ethereum requires cryptocurrency, which is stored in a wallet. That wallet connects to dApps, acting as a passport for the Ethereum ecosystem. From there, anyone can purchase items, play games, lend money, and do all sorts of activities just as they do on the traditional internet. Only the traditional web is free to users, as they're giving away personal information. Centralized entities running websites then sell that data to make money. Cryptocurrency takes the place of data here, meaning users are free to browse and interact anonymously. This means dApp use is non-discriminatory. For example, no lending or banking dApp can reject someone based on their race or financial status. An intermediary can't block what they consider a suspicious transaction. Users control what they do and how they do it, which is why many consider Ethereum to be Web 3.0, the future of web interaction. What does Ethereum do? Decentralized finance has arguably been the Ethereum network's biggest achievement. The apps that can perform several functions within the ecosystem popped up around 2019 and 2020, and are growing in popularity by the day. The more dApps are used, the more the Ethereum network will be used as a result. Ethereum's DeFi scene is the biggest one out there, with successful dApps bringing more awareness to the platform over the years. Artists, for example, are making millions of dollars by bringing their work to the blockchain via non-fungible tokens or NFTs. One might wonder, why buy digital art when we can just screenshot it? Collectors want ownership. That's why. NFTs also hold proof of ownership and serve as a secure form of storage. It's basically an all-in-one for collectors, so it's not hard to see the appeal. It's the same reason that one would want the original Mona Lisa over just a copy, even if a copy is indistinguishable from the first. NFTs also represent usable items and accessories in online games. Players can decorate their houses and characters with unique assets from artists, providing yet another income stream for creatives. Developers have built uncensorable social media apps, allowing users to tip one another for content. Games allow users to invest in assets, play to grow them, and then sell for a profit, extracting actual value from their game time. There are prediction platforms that reward correct forecasts and freelance platforms that don't take a huge cut of each payment. This is all managed autonomously through blockchain and smart contracts, with DeFi putting users more in control of their funds than ever before. Aside from decentralization and anonymity, Ethereum also has various other benefits, such as a lack of censorship. For example, if someone tweets something offensive, Twitter can choose to take it down and punish that user. However, on an Ethereum-based social media platform, that can only happen if the community votes to do it. That way, users with different viewpoints can discuss as they see fit, and the people can decide what should and shouldn't be said. Community requirements also prevent bad actors from taking over. Someone with ill intentions would need to control 51% of the network to make a change, which is nearly impossible in most cases. It's much safer than a simple server that can be broken into. Then there are smart contracts, which automate many of the steps taken by central authorities on the traditional web. A freelancer on, for example, Upwork must use the platform to find clients and set up payment contracts. Upwork's business model takes a percentage of each contract to pay its employees, server costs, etc. On Web 3.0, a client can simply write a smart contract that states if the work is turned in at X time, the funds will be released. The rules are hard-coded into the contract and cannot be tampered with by either party once written. It's also getting easier than ever before to acquire Ether. Companies like PayPal and its Venmo subsidiary support purchasing crypto with fiat currency right within the application. Considering the millions of customers on each platform, they're bound to get involved sooner rather than later. While it sounds like the perfect platform, Ethereum has a few key issues that need to be worked out. The first is scalability. Buterin envisioned Ethereum the way the web is now, with millions of users interacting at once. Due to the POW consensus algorithm, however, such interaction is limited by block validation times and gas fees. Furthermore, decentralization is a hindrance. A central entity like Visa manages everything and has perfected the transaction process. Second, there is accessibility. As of the time of writing, Ethereum is expensive to develop on and challenging to interact with for users unfamiliar with its technology. Some platforms require specific wallets, which means that one must move ETH from their current wallet to the required wallet. That's an unnecessary step for users ingrained in our current financial ecosystem and not beginner-friendly in the slightest. Sure, PayPal is adding crypto support, but users can't do much aside from holding it there. The platform needs to integrate with DeFi and dApps to increase accessibility in a meaningful way. The platform does have some well-written documentation on the matter, another key way to bring in more users, but the act of actually using Ethereum needs streamlining. Learning about blockchain is very different from using it. Ethereum is slowly upgrading to its 2.0 version, which is expected to bring a proof-of-stake consensus algorithm. Planned to occur sometime in 2022, the traditional Ethereum network is working on merging with the Beacon chain, Ethereum 2.0's first new feature. The Beacon chain doesn't change much at first glance, but it adds the foundational changes necessary for future upgrades, such as shard chains. Remember the scalability issue discussed earlier? Shard chains and the process of sharding are a big part of solving any scaling issues. Sharding is the act of spreading transactions across multiple, smaller blockchain networks. These smaller networks can be run by users with weaker hardware, as they need only to store information from said shard, rather than the entire network. Essentially, sharding makes Ethereum validation more accessible and helps to decongest the main network. Ethereum 2.0 has many cryptocurrency enthusiasts feeling bullish. Celebrities are taking advantage of NFTs, and the increase of general blockchain awareness is growing. However, all of this activity has resulted in high transaction fees and slower validation times, exemplifying the need for Ethereum 2.0. This can create a problem, as fees can cost more than half of the transaction amounts at times. Fortunately, dApp developers are hard at work to make it more accessible for the pending mainstream adoption. Part of that solution is the proof-of-stake consensus, a core feature of Ethereum 2.0, instead of mining, which is energy intensive. Ethereum 2.0 marks the move to a POS consensus algorithm. Proof-of-stake replaces miners with validators, users who store the Ethereum blockchain, validate transactions, and more. They're essentially another form of nodes. To become a full validator, one must stake a minimum of 32 ETH, at least during the early period of Ethereum 2.0. By leaving a computer connected to the network, validators earn ETH as a reward for their efforts. The idea is that those who stake their ETH have the best network intentions in mind and will do whatever they can to ensure its success. Plus, if a validator fails to participate or tries something malicious, they can lose said ETH. The argument for proof of stake is that it is a faster, more accessible form of blockchain consensus. It doesn't require special hardware like mining does, meaning anyone with the funds and a device can participate. In theory, that accessibility should grow the network. The more validators, the more blocks get validated. Extra validators also decentralize Ethereum even more, increasing security as the role expands.